binarize that image. So if a particular pixel is below 125, if the intensity of that pixel is below 125, it's going to be set to 0 or black. If it is above 125, it is set to white or 255. That's all it does. And in the find contours method, we can essentially pass in the thresh value. So let's save that. Let's close this out and try to run that. Type. Okay, threshold missing a type. Okay, I think I forgot one part. We have to specify a thresholding type. So this is cv.thresh underscore binary. So we're binarizing the image basically. Okay, let's run that. And there were 839 contours that were found. We can visualize that. Let's print. Let's display this thresh image. Passing in thresh. Save that and run. And this was the thresholded image. You're using 125. I'll close this out. Using 125 as our threshold value and 255 as our maximum value, we got this thresholded image. And when we try to find the contours on this image, we got 839 contours. Now, don't worry too much about this thresholding business. We'll discuss this in the advanced section of this course more in depth. Just know that thresholding attempts to binarize an image. Take an image and convert it into binary form. That is either 0 or black or white or 255. Now, what's cool in OpenCV is that you can actually visualize the contours that were found on the image by essentially drawing over the image. So what I'm going to do real quick is actually import numpy as np, and after this I'm going to create a blank variable and set this equal to np.zeros of image.shape of the first two values, and maybe give it a data type of, I don't know, uint8. We can display this image, call this blank, pass in blank, just to visualize and have a blank image to work with. Let's save that and go to a blank image. This is of the same dimensions as our original cat's image. So what I'm going to do is I'm going to draw these contours on that blank image so that we know what kind of contours that OpenCV found. So the way we do that is by using the cv.drawContours method. It takes in an image to draw over, so blank. It takes in the contours, which has to be a list, which is, in this case is just the contours list. It takes in a contour index, which are basically how many contours do you want in the image. Since we want all of them, since we want to draw all of them, we can specify -1. Give it a color. Let's set this to BGR, so let's set this to red, 0,0,255. And we can give it a thickness of maybe 2. And we can display the blank image. So let's call this contours drawn, and we can pass in blank. Save that and run. Okay, there was an error. I think this has to be shape. Okay, so these were the contours that were drawn on the image. If you take a look at the thresholded value, thresholded image, it's not the same thing. What I believe it attempted to do is instead it found the edges of this image, all the edges of this image, and attempted to draw it out on this blank image. So let's set this. So let's set the thickness to maybe 1, so that we have a crisper view. Oops. Okay, so these were the contours that were drawn in the image. And in fact, if you try to visualize it with Kenny, let's actually visualize that with Kenny. Uncomment that out, run. Blur's not defined. Okay, that has to be an image. Okay, let's look at Kenny. Let's look at this. Okay, it's not the same thing. And that makes sense because our find contours method didn't use Kenny as the basis of detecting and finding the contours. But we can do that. Let's not use a thresholding method, and instead let's use Kenny. So we can pass in Kenny here, save that and run. And okay, they're pretty much the same thing, right? It's basically a mirror image of these two. Like I said, you can get away with thinking of contours as edges. They're not the same thing, but you can think of them as edges because from a programming point of view, they are kind of like the edges of the image, right? They are the boundaries, they are curves that join the points along the boundary. Those are basically edges. So let's try to blur that image. Let's uncomment that out. Let's see what that does. I don't think that had any effect because we didn't pass in blur. Okay, 380 contours that were found and mirror images of each other. So generally what I recommend is that you use Kenny method first and then try to find the contours using that, rather than try to threshold the image and then find the contours on that. Because like we'll discuss in the advanced section, this type of thresholding, the simple thresholding, has its disadvantages. Maybe because we're passing in a simple, just one value, try to binarize the image using this threshold value, right? It's not the most ideal, but in some cases, in most cases, it is the most favored kind of thresholding because it's the simplest and it does the job pretty well. So that's pretty much it for this video. We talked about how to identify contours in OpenCV, but in two methods. First, trying to find the edge cascades of the image using the Kenny edge detector and try to find the contours using that. And also trying to binarize that image using the cv.threshold and finding the contours on that. So if you have any questions, leave them in the comments below. I'll be sure to check them out. Otherwise, as always, I'll see you guys in the next video.